Welcome students. Let us continue our discussion on the topic impulse momentum by solving some more examples on the subtopic, that is collision. The next question is, a 2 kg ball moving with a velocity of 0.4 meter per second towards the right collides with another ball of mass 3 kg with a velocity of 0.5 meter per second in left direction. Determine the velocity of the ball after impact. So first thing we need to find out is determine the velocity of ball after impact and the corresponding loss of kinetic energy, wherein if E is equal to 1, that means coefficient of retribution is equal to 1, or we can say that the body is perfectly elastic. Second case, E is equal to 0, that is coefficient of distribution is 0, or I can say body is completely plastic or perfectly plastic body. And the third case is when the material or the contact surface is having a coefficient of distribution between 0 and 1, that is 0.7, wherein I can say it is neither pure elastic nor purely plastic. So the things given are, there is a ball of mass 2 kg moving towards right side with a velocity of 0.4 meter per second, and this ball B of 3 kg is moving towards left side with a velocity of 0.5 meter per second. The first thing which we need to find out is when these two balls will collide. After collision, what will be their velocities? That means we need to find out what will be VA and what will be VB. So in any case, we know that momentum is conserved. So let us first start with this case 1, that is when E is equal to 1. So again I will write case 1. We know that initial momentum is equal to final momentum because momentum is conserved. I will write down the equation for initial momentum, that is MAUA plus MBVB, and final momentum is MAVA plus MBVB. Now we will substitute the values which are given to us in the question. For example, MA is given to us as 2 kg, UA is given to us as 0.4, MB is given to us as 3 kg, and UB is given to us as minus 0.5 meter per second square. Now why minus? Again because it is moving towards left side as shown in this figure. MA again 2 kg, VA we are required to find out, so it is not there with us. MB 3 kgs and VAB we are required to find out. So let us substitute the values which are known to us, and we will get one equation as minus 0.7 is equal to 2VA plus VB, and let us say this is as equation number 1. Now in the question we are also given E is equal to 1, that means coefficient of retribution value is given. So let us apply that formula. So coefficient of retribution, we know that it is given by the relation VB minus VA divided by UA minus UB, out of which the value of E is given to us as 1, UA is given to us as 0.4, and UB is given to us as 0.5 in negative because it is going towards left side. So substituting the values, I will get another equation as VB minus VA is equal to 0.9. Let this be equation number 2. Now if you observe equation number 1 and 2, the unknowns here are VA and VB, and the unknowns here are also VB and VA. That means there are two equations and there are two unknowns. So what I will do, I will solve this equation 1 and 2 simultaneously. And solving it simultaneously, I will get the answer for VA as minus 0.68 meter per second and VB as 0.22 meter per second. With this answers, we have completed the first part, that is determine the velocity of the ball after impact. Now second part of the question was to determine the loss of kinetic energy. So loss means, if we want to find out loss, what we will do? First we will find out what was the initial kinetic energy, and then we will find out what is final kinetic energy, and we will just take the difference of the both to get the loss of kinetic energy. So let us start with that. We have the formula for initial kinetic energy as half m a UA square plus half mb UB square. we all know that the formula for kinetic energy is half mv square. But as I am using initial kinetic energy, I will write in place of v, I will effect as UA and UB respectively. Similarly, final kinetic energy will be given as half mVA square plus half mVB square. Now why V here? Because we are finding out final kinetic energy. And also we know that loss of kinetic energy is given by initial kinetic energy minus final kinetic energy. Now, when we were discussing about the cases of elasticity or types of distribution of the bodies, we have seen that when E is equal to 1, if you recall your memories, when E is equal to 1, we have said that momentum is conserved and also there is no loss of kinetic energy. So here I will write directly, as E is equal to 1, there is no change in kinetic energy, and this completes the first part of the solution, that is when E is equal to 1. Now similarly we will proceed for the next part, that is when E is equal to 0. Let us start with that. So again, case 2, wherein I will say that case 2 wherein E is equal to 0, again we have the momentum has been conserved, so I will write initial momentum is equal to final momentum, for which I can write MAUA plus MBVB is equal to MAVA plus MBVB. Now from this equation I have the values of MA, I have UA, I have MB with me, I have UB with me as minus 0.5, MA is available, MB is available. I will get one equation in terms of VA and VB. Now just a point worth noting. In previous case, when we were solving for E is equal to 1, we have again used the same equation and nothing has been changed in this. So you will observe that if I substitute the values, I will get equation number 1 same as that we got in the previous case. So you no need to solve again for the equation 1. But yes, there will be change in equation 2, because equation 2 was derived in previous case. It was derived by using the formula E is equal to VB minus VA divided by UA minus UB. Here we have used E is equal to 1, but here in this case we are given that E is equal to 0. So this equation will now change. So let us start and see what will be the next equation. So again, writing the formula for coefficient of distribution and substituting the values, I will get the equation as VB minus VA is equal to 0. Let this be equation number 2. Now if you observe equation number 1 and 2, again there are two unknowns and there are two equations. Solving it simultaneously, I will get answer for VA as minus 0.14 meter per second and answer for VB as minus 0.14 meter per second. Both the answers are getting same. Again recall your memories. While studying the types of distribution on the bodies, we have seen that when the body is perfectly plastic, the momentum is conserved, and we have said that both the balls will move together as one unit. So as they are moving together as one unit, you can observe here also velocities of both the balls are same after the impact. So with this we have completed the first part, finding out the velocity of the ball. Next part was finding out loss of kinetic energy, for which we need to find out what is final kinetic energy and what is initial kinetic energy. Let us start with initial kinetic energy. I can write half MUA square plus half MUB square. On substituting the values, I will get the answer for initial kinetic energy as 0.535 joules. What I have done, I have just done the substitution of mass and velocity, which were already known to us in the question. Now, next step will be to find out final kinetic energy. What will be changed? Just change will be in place of U, it will be now V. So yes, I have written the formula. Final kinetic energy is equal to half MAVA square plus half MBVB square. Again, we have all the things with us. VA and VB we have just found out as minus 0.14 meter per second. Substituting this, I will get the answer for final kinetic energy as 0.049 joules. Now we need loss. Loss of kinetic energy means initial kinetic energy minus final kinetic energy. So on substituting the values as 0.535, and 0.049 for initial and final kinetic energy respectively, I will get the answer for loss of kinetic energy as 0.486 joules. With this, we have completed the solution of the second part wherein E was equal to 0. Now let us proceed similarly for the third case wherein we are given that E is equal to 0.7. So let us start with that. So in case 3 also we will write initial momentum is equal to final momentum. Then for initial momentum we can write MAUA plus MBVB is equal to, for final momentum I can write MAVA plus MBVB. Substituting the known values, I will get one equation as minus 0.7 is equal to 2VA plus 3VB. Again, if you observe, this equation 1 is exactly similar what we have found out in case 1 and case 2. So in exams, you don't have to rewrite this particular set of equations. You can directly write from giving the reference of the above cases. But for second equation again it will change because now the value of E has changed to 0.7. So writing the formula for E, I will get E is equal to VB minus VA divided by UA minus UB. Substituting the values, I will get the equation as VB minus VA is equal to 0.63. Let this be equation number 2. Now observing equation number 1 and 2, there are two unknowns VA and VB, and there are two equations 1 and 2. So solving equations 1 and 2 simultaneously, we will get the answer as VA is equal to minus 0.518 meter per second and VB is 0.112 meter per second. This completes the first part, that is determine velocity of ball after impact in case wherein E is equal to 0.7. Next part asked was loss of kinetic energy, for which we find initial kinetic energy and final kinetic energy. So for initial kinetic energy I will write half MUA square plus half MBUV square. Substituting the values, I will get the answer for initial kinetic energy as 0.535 joules. Again, point worth noting, initial kinetic energy will exactly be same in all the cases. So again you no need to find out again, you can just give the reference of previous case in the examinations. But yes, final kinetic energy will be changed because now the velocities after impact has changed to minus 0.518 and 0.112 respectively. Substituting the values, I will get the final kinetic energy as 0.287 joules. Now we need to find out what is loss. So loss is given as initial kinetic energy minus final kinetic energy. Substituting the values, I will get the answer as 0.248 joules. So with this we have completed all the three cases wherein E is equal to 1, that means perfectly elastic bodies, E is equal to 0 wherein the bodies are perfectly plastic, and third wherein E was given to us as 0.7 where the bodies are neither purely plastic nor perfectly elastic. And we have found out the values of velocities of ball after impact and the corresponding loss of kinetic energy as required in the question. Hope you have understood the concept and the procedure for solving this kind of problems, and now you are sure that you can solve any problem of this kind. Thank you.